Okay. I think we should get started. It's already 10 minutes. We will let them join. Good morning. Welcome back to the fifth session of our discussions. The last class, we talked about how the science started by mimicking the nature, and science was carried out in the form of debates, and most of the time it was done by authorities. I mean, they say that this is works like that. People kind of accept it. So these are all called. This is all like the way science happened. And then in Greek sciences, we had a lot of science coming up in the form of mathematics, astronomy, and all. More like pre-Socratic era, especially Pythagoras school of thoughts. Following that Euclid's geometry and all, they call it pre-Socratic because they are all just before Socrates. But with Socrates, arrival of Socrates, science took the way science has been done was a little different because Socrates gave a way of um, getting into a debate, first argue for one side and then prove or disprove, and then take the exact opposite and argue from the other side. And based on this dialogue, he's told that we can arrive at truth. So that's one way of doing science, of course. Then there were people started asking for the fundamental particles, and the term atoms started appearing, and people started seeing how people are seeing. Especially Euclid said that something from the eyes rays go and get reflected and come back. So that's how we see. Those kind of descriptions started coming up. So slowly it started happening. People started documenting it. And then the Library of Alexandria is probably one of the first state-sponsored library. This one now it is burnt out, and for some reason I don't know. But we still have the remains of it. This is a very, very historically important place. People go and visit. Then we have this geocentric model by Ptolemy appearing. People started talking about how the heavenly bodies move around. And then Ptolemy gave a very nice mathematical model for it. On the Indian subcontinent, that area, we had a lot of developments of mathematics, astronomy, Aryabhatta, and others, Bhaskara and all, were arriving at numerical number systems and using zeros and without any problem. Especially zeros were a dangerous idea for Pythagorean sciences because it is very difficult to show a area of zero size or a area or line of 0 centimeter long. All these things are not possible in geometry. So Pythagorean sciences were avoiding zeros and irrational numbers, right? Like root of 2, pi and all. But Indian number system were happily using it. Then in India, we have this nice another state-sponsored university, Nalanda. It's a Buddhist monastery kind of place where people from all over the world came, did philosophical debates, religious learnings, all these things happening. Well, these are all happening. Christianity also started becoming a more influencing religion. So in the Europe or in Greek, and the rules changed. Religious things came into authority, religious bodies, and becoming more and more organized. And big what to say, thought-provoking changes stopped appearing. That's when we call it dark age. So we stopped the last session with the arrival of dark age. Now we will proceed with the session 5. So while the world is in dark age, Islamic religion also grew. That started spreading across different areas, especially towards east, and it captured a lot of places. The Islamic kings captured lots of places. The great thing they did was they took the science from Greek and India, and they translated it to Arabian languages. And then from there, it translated to Latin, and it went to Europe. So 18th to 14th, 8th to 14th century, we call this Islamic sciences. Lot of improvements, lot of developments in various areas happened. We'll see a couple of examples. So this work by Al-Khwarizmi, I don't know how to pronounce it. So Al-Khwarizmi work on algebra, astronomy of 8th century. It's an excellent example. So this word, Latinized word of this is, they call it algorithm. And from there, we have this word till has a lot of developments in computer science. We use this word algorithms, right? So this is coming from this scientist, in the name of this scientist, right? And then there's one more excellent contribution by Al-Hazen from present-day Iraq. Published a book on optics. So this is one place where there's a completely opposite way of looking, right? Light. This book promotes the idea that light enters eyes instead of previous Euclid's proposal that eye flashes something into the objects and seeing. But that Al-Hazen's response to it is to it proposes that light enters eyes. Right? Lot of his work was cited by Newton, Galileo, Kepler, and Huygens, who were all who came later and post Renaissance scientists, right? So such an influence the Islamic world made by translating, developing further the existing sciences and taking it to Europe, where the environment is becoming very conducive for the next step of major developments. So this is another example where the numerical system that we currently use, how the Islamic world took it from Indian number system and took it to Europe in the form of our current form, right? This current form. Okay. I don't know why my pen is, yeah, okay. This form we are currently using, right? 1, 2, 3, 4, 5, 6. That form is arriving only in 16th century. That is taken, there's a contribution from Islamic world. to Europe, and then European scientists took it and started developing. So with all this, Europe now got the required mathematical tools and the ideas from various places, especially from Indian subcontinent and from Greek background, Greek sciences. So that it started developing its own. I mean, the world is now taking the next step from here. So Roger Bacon, one English philosopher who lived in 12th century or 11th century CE, published several works taken using Alhazen's science, and he took it forward. Especially major development is questioning the authority, right? So using Alhazen's empirical methods, Roger took a completely different way of doing science, right? So he started, he checked what was Aristotle's observations and what is the empirical, using empirical methods, verified it and started questioning and the predictions he made, and then but that was not in sync with Aristotle. So that is one major step forward, because more than a technical breakthrough, it is asking or questioning the authority, right? That is very important in science. In Tamil, I used to quote this Thiruvalluvar's couple of greatest poems, right? எப்பொருள் எத்தன்மை தாயினும் அப்பொருள் மெய்ப்பொருள் காண்பதறிவு, எப்பொருள் யார் யார் வாய்க்கேற்பினும் அப்பொருள் மெய்ப்பொருள் காண்பதறிவு. It translates in a high level, it translates like this. So whoever says something, you question it and arrive at the real knowledge. And other poem is whatever may be the character of certain things, you question it, you arrive at with your own knowledge, your own thinking or your own knowledge, right? So that is what is intelligence. That is what Tiruvallur says in these nice poems, and I think it's an excellent example. Roger is an excellent example, right? So he started questioning the observations made by predictions made by Aristotle, and trying to verify it with the empirical methods. So he also introduced optics into the university curriculum. That is one of the major steps forward, because after this step, if you see, a lot of people started learning or asking questions about light. We have several scientists coming later, questioning about light and how we see, etc., etc. All these things was laid down by bringing it into university curriculum, right? So it's one of the first steps, right? So Renaissance starts. We are all ready to move forward, and but still very silent. But artists took. So when we say Renaissance, it is not only in science, right? It developed things in all directions. Paintings, writings, all these things made a major leap forward. So that's why it is Renaissance, right? So artists took it, the development of geometry and perspective geometry, and they used it extensively in their paintings. Some of these paintings, for example, if you take in this 13th century or in 1400s, you see that initially before this period, the paintings usually looked flat. But after this geometrical development and all, you see they specifically used this single vanishing point based on paintings based on single vanishing point, double vanishing point. So in this painting, if you see here, the vanishing point is somewhere here, right? Sorry, somewhere here. So all lines converge there, and based on that, they made a painting. So Da Vinci's Jesus, right? Last Supper. That's also another great example. So this painting also, if you see, vanishing points are, so lines go from here, right? So vanishing points. Perspective geometry is heavily used. So paintings and other forms of art and all started developing and using these latest developments in mathematics, science, and philosophy. That's all people started using. So one of the very early or first contributors in the Renaissance period is we see Nicholas Copernicus.
This is Prasanna.
Sorry.
This is Prasanna.
Hi.
I just wanted to add one thing. In your last slide, it was very nicely mentioned. The artist took the scientific thoughts and started incorporating. So, which means art is not different from the science. Actually, it is all integral of things. But I find these days there are courses being floated without even mathematics and this. So I wonder that such things rather should always have these fundamentals. Need not have a deeper, but it should have the fundamentals of all the sciences for any art forms also. There are many
Actually, can I
sciences.
also add some points? I mean, I was very thanks for sharing about this point because I'm actually an art educator and I teach perspective art. So that's what you said is actually very true. The integration of optics in art and science and art are close together in terms of what its objectives are, but somehow there seems to be a a deviation where art has gone to one side and science has gone to one side. I'm also a doctor, by the way, so I try to bring both these elements together. So that's a very nice point from the historical perspective in Renaissance.
Yeah, thank you. Interesting observations. Thank you. So yeah, I also do a little bit of painting here and there. The way it develops, right? Closely, very, very closely with the mathematics. I can relate it. For example, in this period, if you see this painting that we are seeing in the screen, it is more a realistic painting, right? They try to depict exactly what they were seeing, and they wanted the artists. They wanted to be really. They say that they wanted to be truthful to the nature of appearance. But if you see the paintings now, realistic painting, yes, of course, it is there, but people want to see abstract paintings, right? Mathematics also have gone very, very abstract. Number systems and all have developed highly. And we have not just 3D calculus, now Riemann calculus, if you see, we have 5-dimensional geometries, multi-dimensional geometries, and string theory. We have very, very high abstract 10-dimensional space and all, right? So as mathematics goes very abstract, art goes hand in hand, and it's very
Hello.
That's what also I have. Hello.
Hello, sir. I just wanted to mention one more point. I read somewhere that during the time when Einstein proposed general relativity and Eddington was trying to prove it empirically, during that time also there were a lot of art movements that started. For example, Cubism. They were trying to. They were inspired by the fact that you could that there was no single privileged reference frame. And so they were trying to see the same thing in different perspectives.
Yeah.
So that was, I think, one of the influences of Cubism,
Mhm.
that
Yeah.
general relativity, and it inspired them. It didn't
Yeah.
necessarily directly influence the nature of the drawing, but it
Mhm.
definitely influenced the. So just
Definitely.
one small point. Yeah.
Yeah. Thank you. So that's what. So art and science go hand in hand, definitely. So we see this developments going through in very well in the Central European artists among Central European artists. So one of the major development or scientific revolution that was done in the Renaissance period is done by Nicholas Copernicus. We all already heard about Copernicus in our curriculums. What he asked is, we are all observing heavenly bodies from Earth. What if we observe it from other places? So his favorite observation place is from sun. So he started thinking, what if you observe it from sun, right? So Copernicus published a book called On the Revolution of Heavenly Sphere in 1543. They proposed this heliocentric model. What it talks about is sun is at the center, not Earth as previously thought. Sun is at the center, and all other planets revolve around it in a circular orbit. He did not know about elliptical orbits, but based on his observation, it is a circular orbit. Luckily, he did not have any problems with the church because of this change, because at that time, as you know, it is just coming out, Europe is coming out from the Dark Age. A church was very particular about the way what people are saying about the God's creation, right? The God's creation of Earth, where the people live, it should be center of the universe. It cannot be other way around. But on the revolution of heavenly spheres, Nicholas Copernicus gives the exact opposite. But he received this book. The book got published on the day he died. So he did not have any. He did not have to face the authorities on what happened. What could I don't know what I couldn't imagine what could have happened. But definitely, from what we are going to see on Galileo's case, it would have been a major blow to his scientific career itself if had he faced this book's publishment before his death. But so actually another scientist who called Bruno took his idea and started popularizing. He himself was a major revolutionary person who was talking about a lot of things about atheism and all. He was a major Copernican model popularizer. So he was punished because of this and burnt alive because of blasphemy and questioning authorities, right? So that was the scenario still. Though Europe came out of darkness, it was not very easy to just publish something and something that is contradicting Bible and get away with it. It was very difficult. But scientists continue, right? So in Nicholas Copernicus model, the planetary orbit is circular. Sun is approximately at the center of the orbit, and the speed of the planet in the main orbit is constant. So these are all the major laws according to Copernicus. Of course, this is going to change soon. We will see how. But but the main idea is diverging from the Ptolemy's geocentric model and goes to heliocentric model with the planets orbiting around the sun instead of other planets and sun orbiting around the earth, right? So that is a major jump for which people supported this model got punished. So one of the major inventor, or what I say, a revolutionary scientist, according to me, is revolutionary, not just a scientist, is revolutionary because he did a lot of things to question not only church, even authorities in science themselves. So one of the major practical, one of the major contributor to the current scientific, the way we do science, right? So that is done by Galileo. So that is a regular practical inventor. So what he did was is that he realized that there was a invention. He heard about this invention from a lens manufacturer, that with some arranging it in some way, he can magnify, right? So Galileo immediately realized what is the importance of it, and he improved it. A lot of times in our books, we have seen Galileo invented telescope, but Galileo didn't invent the telescope. Galileo improved the telescope, and then he pointed it to identify or observe the sky, observe the sky and other planets, right? So one thing about this telescope is it can also be helpful in seeing the enemies from a distance, right? So Galileo's inventions and all are already very popular, and he already has some influence in among the kings and authorities and all. Already as known as a scientist. So his he was such a great scientist when he was when he was living and inventing and all is going on. So one of the major thing about Galileo is creator of modern scientific method, as we discussed, right? So if you see his way of doing science, again, the way science is done is changed. So build apparatus, do experiment, publish the results. So that was his step forward. So what happened is, again, this is a deviation from Aristotle and others who have who did science before based on authority. Right? So they started, Galileo's way started questioning. Especially you might have heard about this famous experiment from Pisa Tower by Galileo, right? We don't know whether that experiment happened or not, but Aristotle's statement was that when two objects fall, the lighter objects will fall slower and the heavier object will fall faster. So that was kind of, world took it, nobody questioned. But Galileo, instead of just accepting or questioning, he just did that experiment and observed that both fell at the same time. So that is kind of way he did science. So experimental science, as we know now, right? Give a theory or make a hypothesis, devise an experimental setup, do the experiment and find the results. That kind of modern scientific method is given to us by Galileo. That was the major step forward in developing the scientific enterprise.
Just to add, since Galileo is being talked, he has done some, as you said, some amazing things. And since, although at that time, most people are not just assigning themselves to a specific discipline, they are more of a philosophers, basically.
Yeah.
So he could relate what we don't usually can relate these days very easily. For example, it seems Aristotelian view was every body prefers to be at rest, non-moving condition. That was the basis of many of his derivations, which means I see something today, next day I keep it in the same place. Unless some external disturbance is there, it will always be in that place.
Yes.
We had a fancy name of inertia now, or resistance. He didn't frame that. But Galileo, by his telescopic observation, he claimed that need not be the case. A body can continue to be in its present state unless disturbed. He just slightly modified that.
Yeah.
It need not be at rest. That nearly changed everything, because people thought external supreme source is required to move something like a planetary body. He just changed the view, saying that if it is already in movement, it will continue to be in that state only. So whatever state it is, it will continue to be there, unless you somehow disturb it. That was one of the things. Subsequently, Newton took all these and nicely consolidated into equation form. So maybe, as I said, Galileo may require multiple sessions also to enjoy all his thought process and philosophies, including gravitational experiments. What he did. Just wanted to mention that.
Sure. Yeah. Thanks, Prasanna. Yeah. Of course, yeah. When we talk about Galileo, a lot of things will come because he has done a lot of changes the way we do science, right? So this is a couple of small devices he invented. I took it from Wikipedia. So continuing on, Galileo, so far so good. Everything is nice. But he turned the telescope to heavenly bodies and observed that moon is also a terrestrial body like Earth. Initially, it was not believed that way. Moon was not thought to be a terrestrial body. Some people even have it's a butter roaming around in the heaven around the Earth. But Galileo told that this is not the case. Moon is like regular, like our solid sand, rocks, etc. are there. So this is his own watercolor images that he drew after this observation. So he published a book called The Stray Messenger, talking about all this. Okay, now this is all fine, but this did not go unnoticed. Of course, book becomes famous, but the authorities, especially the church, was not very happy. Already Galileo got a warning because of his way of doing science. He already got a warning that you cannot do such activities. You see some message here, 1 minute. Oh. So this authority, they tried to tell him that, okay, since Galileo is already a very known scientist, they were kind of gave a warning, but that didn't stop Galileo. Galileo was already into some very deep another work. He published another important book called Dialogue Concerning Two-Chief World System. This is an excellent, nice book. Of course, it landed Galileo in a lot of troubles. But the idea of this book is that he wanted to support Copernican model, but he didn't want to directly tell it. this book has three characters. These three characters, they argue one will be for Copernican model, another will be for geocentric model, and then one very innocent, like questioning friend. They three argue. So Galileo was aware of that this may upset the authorities, especially church. So he did not directly tell that Copernican model is correct in this book. But whoever reads the book, they will arrive at the conclusion that what Galileo wants to tell. So that is the way this book is written. It's an excellent read. Of course, little tough reading. At least for me, it was little tough. But it was nice way of writing. So Galileo wrote this book and published. That landed him up in a lot of troubles, right? Church started its trial on again accusing Galileo of blasphemy. The charge is like he is leading the younger generation with the false ideas and giving the wrong directions and all. Galileo actually, in fact, he talked to the authorities before publishing the book. He was named that authorities will, given the facts with the proper argument, logical derivations and all, they may accept. But he was wrong and he was made to confess. In spite of a very known scientist, he was made to confess that he did not hold Copernican model anymore. He was made to kneel when the sentence was given. So in spite of all these things, he accept. So in spite of all these sentences and giving up Copernican model, he was still put into this house arrest, right? He was almost blind during the house arrest, but he did not rest easily. He started writing further books on kinematics and strength of other sciences. Other strength of material. So all these things were still, though the Europe came out of this dark age. Galileo was one example where what will church do if you go against it, even if you are a very well known person and has done a lot of important work in contributing to science. So that is something that it happened to Galileo. So why Galileo seems to be such a great scientist is, it's not just, as I told, it's not just a technical contribution. It is relentless fight to arrive at the truth, right? So that is something that inspires me towards Galileo. Yeah. So that is going on. Two contemporaries of Galileo made significant contributions as well. So Tycho Brahe, he was meticulously observing the heavenly bodies. He's probably, but did not have a telescope because Galileo's telescope still has not reached him while he was alive. He kind of did a lot of observation, noted it accurately in his notebooks, but he did not have a mathematical model or did not know how to fit these observations and arrive at a decision. He gave his own model called geoheliocentric model. I don't know what that means. So it's kind of, he still says that our planet's revolving around sun, but sun still revolving around Earth. So he couldn't give up that completely the Earth center of Earth. He still couldn't give up. So he continued to hold geocentric model, but still his observation was different. So he had to arrive at this geocentric model. Yeah.
If you look up the word epicycloid, like we do in our younger age, one gear in the center, one more gear at the. We try to make patterns by rolling one gear over the other by putting a pin.
Mhm.
So he was trying to propose that. Epicycloid became very famous at the time. Epicycloidal model.
Okay. What is this?
Maybe
What is that model?
like we create column, whatever we try, like one pattern moving over the other pattern. It can be created by keeping one gear in the center and moving another gear around it. You put
Okay.
a pin. So it starts seeing the Earth can be in the center. Sun can rotate around the Earth, and few things can rotate around the sun.
Okay.
So it's like encompassing all the available beliefs then.
Nice. Okay.
And this guy can be a benchmark for patients, because nearly for 40 years, all he was doing is seeing the night sky and charting it.
Exactly.
He's
Yeah.
very famous for. Okay. Just wanted to
Very patient observation and accurate recording.
Yes.
Yeah. So that is one major contribution. But then the geoheliocentric model was still not right, which was actually corrected by Kepler. Kepler was an excellent German astronomer and mathematician. He met Tycho. He was trying to find a job and he met Tycho. Tycho wanted to use Kepler's mathematical abilities to see whether he can fit his observation into mathematical model. So we all know Kepler's law of planetary motion. So Kepler proposed these based on this mathematical model. He proposed this his way of looking at it. So you all know that now we know that the planetary orbit is not a circle. It is elliptical orbit, right? So he saw that the data fits this only elliptical orbit. So the first law, we know that it is elliptical orbit, and sun is not at the center, but at the focal point. Sorry, not at the center of the circle. Of course, we said it's elliptical. It is in one of the foci, right? Elliptical orbit will have two centers. Sun is in one, not at the center of this ellipse, but it has the one of the foci. So that is the second another proposal from. I'm not exactly describing this as we see it in the book. So it is like a little bit of our way of telling how this laws work, right? And then one of the another major contribution is that it is not circling at the same speed. It is not a constant speed. It is actually a when the Earth is far closer to sun, or any planet closer to sun, it has to go faster, because when it is closer, since it's elliptical orbit, at certain point it has to be closer, right? So when it's near the sun, it has to travel fast to avoid falling into the sun, right? So that's why it talks about. So this second law talks about that planets are not traveling at a constant speed. It is at a different speed. So just quickly, I wanted to show this. See this? This is from Wikipedia only. So when it comes here, when we see it here, it has to go very fast because sun is here. it has to go very fast. Otherwise, it will fall inside the sun. So this is another law. So there is a nice YouTube video also. Just a 1 minute video.
Johannes Kepler published 3 laws of planetary motion, the first 2 in 1609, and the third in 1619. First law. The orbit of a planet is an ellipse with the sun at one of the 2 focal points. Second law. A line segment joining a planet and the sun sweeps out equal areas during equal intervals of time.
Don't worry about this equal area sweeps out equal areas in equal interval of time. It is okay if we are familiar with physics, but for non-physicists, it is better to just know that it has to go faster when it goes closer to sun. See that? So all this law talks about it. This area and this area are same. To cover this area, it has to travel faster here. So that's what it talks about. But we all know that it has to travel faster. It's an easier way of understanding the second law. Don't worry about third law. It's a little complex. We will we can do it, or you can do it on your own. Find out what it is about. I'm not going to talk about it. So, but what we want to emphasize here is that a step-by-step process, right? We had a geocentric model. Then there is a heliocentric model with the sun is at the center. Everything is revolving around in a circular orbit and at a constant speed, right? Then later we have this Tycho Brahe's geoheliocentric model. And then we have Kepler finally corrected everything and told that it is not in the center, it is in elliptic, it revolves around in elliptical orbit with sun in one of its foci. And it is not traveling at single or constant speed. It is going at a different speed to avoid falling. Okay. Thanks, Judah. So that is a Kepler. So we saw Galileo, we saw Tycho Brahe, and then we have Kepler, and we already saw Copernicus. These are all important people, especially with Galileo giving a way of doing science, arriving at a, experimental methods or mathematical models, understand it and understand it and proceed, right? To verify your theory. So that is the way we do science now. So now we already, when we talked about family and all, we gave a definition. Now, shall we have a definition for our discussion going forward? So what is science? So I came up with this definition. It's an accumulated and curated facts. Of course, this is different places. I see different definitions. So combining this, I have this in my mind. It's accumulated and curated facts about nature. Especially this is about natural science. We are not talking about social science. Social science has a different little. It is not that. What is it? Very strict, like natural science. Natural science is very strict. So it is to be verified, to be experimentally verified. So accumulated and curated facts about nature, which can be verified by anyone experimentally or empirically or theoretically, right? So that is what we call about, we tell what, when we say what is science. This is what we have as a definition. Okay. So this is all I have today. I did not know how quickly or slowly we will go. So I wanted to just come up with a definition and take this the next step forward. So of course, these are the books. This Galileo Antichrist, Galileo's biography by Michael White, is an excellent read on Galileo. And A Brief History of Time by Stephen Hawking is always a good source for reference. Ascent of Man by Bronowski was also a good reference for us, helped us to come up with this session. So any other discussion? Looks like I thought this would go slowly, but we got a little faster. Not a problem. Yeah.
This person, I saw a comment by yours in the chat session about eccentricity. What he mentioned is right. This what he had put in the chat session was, though it is, we say it as ellipse, it is more circle-like.
Yeah.
That is very true. Actually, that is how many observations, even as you were pointing out, Moon was considered to be a creation of perfectness, which Galileo broke by the observation, showing that it is having craters and surface imperfections. So as we observe things in a more close, we try to understand better and try to fit a better model. So as he mentioned, the eccentricity is so small, it for many reasons it can be still considered a circle. That is why many books still put nicely a circle for Earth's orbit or Moon's orbit.
Yeah.
For the purpose of that level, it is okay to approximate it, like we do round of things.
Right.
So, but as we go for a more better understanding and to get more correct results as we scale up our things, like for satellite conditions, say, then these starts affecting us, because unless we use this eccentricity, we won't get the right predictions. Then we start incorporating these eccentricities into our model. So based on our progress of thoughts and requirements, these things gets refined. So what he said is right. It look circle-like. That's why they started thinking it is circle. Now we are refining it to ellipse. Understanding the eccentricity of it, how it is offset from the circle-like condition. And that's why we, like we discussed last time, we even use the word eccentric in the English way to say that somebody who is not in the right path.
Yeah.
So these are all came out of, I mean, we borrow from literature, borrows from the science, and science borrows from literature, and so on. I hope that clarifies. I mean, you guys put the chat box. I thought I will just comment on it. Thank you.
Thank you. Any other questions, comments? Okay. So yeah, so we will go further. So we have so after this, of course, you all know that how it made progress. We have heat, light, and then we see that excellent contributions coming, describing this electromagnetic theory of light. And then we have relativity, quantum mechanics, and I recently read this book called Escape from Shadow Physics by Adam Kay, which talks about the hidden variable theory of quantum mechanics, which can be used to avoid uncertainty and come up with a better description of the world. So it's still that debate is going on. Let us see how it goes. Okay, thank you. Thanks very much.
Yeah, thank you so much.
Thank you.
Balaji, so we'll have the session next Sunday only, same time?
Yes,
Okay.
that is better, right?
Better, I think. I think even the attendance is not very big. I see all of them very serious about it. And the discussions and other things. Maybe it's Sunday is better.
Yeah, I think I
So-
can have more slides actually, because I thought I prepared for everybody, which is why I had it very small number. Maybe thinking that I had to go through more talking in this each slide, but as you know that participants are all already know a lot of these things. Maybe we went very fast.
That's good. I mean,
So what will
lot
be
of
covered
e-learning can
next week?
So that's what I want to go on this. After that, after Galileo, we want to see how Newton's experiments on optics and three law of motions. What is the next contribution? And then, of course, Newton's idea was based on force, because the idea of energy was not there. Then we jump into what is meant by energy. What are the experiments done in thermodynamics of two law of thermodynamics, and then we go on like this. Any specific things you want to see are covered?
Nothing specific, sir. Can I add Darwin to the group?
Sorry,
He's
what?
can I add Darwin to the group?
Yeah.
Yeah, of course. Why not? Any serious learner or contributor can be there.
Okay, sir. Thank you.
So when can you can talk, right?
Sure, sir.
I do have Darwin in my successive sessions, definitely. Darwin and Mendel we want to talk, but a person from biological background, if here she talks, that will be great.
I would love to talk, sir. I would love to talk about Darwin.
So sorry, come again.
I would love to talk about Darwin. Sure.
Excellent. Now, okay. So maybe next to next session we will talk about it. That's how I have planned.
Okay, sir.
Yeah. A question to Darren. Hi, Darren.
Hi.
You said you are teaching art, right?
Right.
So what are you doing?
As in with regards to the art, or like, is it a broader question?
It's regarding art.
Oh, right. So basically, I teach perspective drawing
Okay.
for these NATA aspirants.
Okay. Do you
Yeah. Sorry,
do
yeah.
painting as well?
Yeah. I'm also, I freelance as a visual artist on the side.
Mm-hmm.
So I do several things. So this is like a small part of the work I do. And I also teach so I had a lot of interest in perspective and optics because I also do these anamorphic illusions, like, those 3D street arts.
Mm-hmm.
Like when you use a camera, basically it's called forced perspective.
Okay.
So if you see from one angle, the object in front of you looks three-dimensional.
Mm-hmm.
But if you look from any other angle, it looks distorted.
Okay.
So I remember teaching myself like some basic geometry and thinking in terms of optics as well, because I conduct workshops on that art style.
Okay. Okay.
Yeah.
I see. So I do some watercolor and oil paintings.
Okay.
Just like a hobbyist. I'm not a trainer.
Right. Right.
So just as a hobby, I do it.
That's wonderful. But what do you do other like you're a physicist, is it? Or like a
Computer programmer. I'm a software
okay.
developer. Yeah.
Okay. Okay.
You work in
That's wonderful.
yeah.
Yeah, I think I really love that point because like I struggled with this a lot because one of my like my thesis in college was based on trying to use drawing as a learning tool for
Oh,
model-based reasoning. So I did a lot of research on, how science has benefited from models. So especially when you were talking about the Kepler model and all, this was something that even I have spoken about, how models can both be useful and constraining in terms of, especially if you want to like think and create new information.
okay.
So a lot of resistance from my peers and colleagues because they felt that art has no space in science or medicine. It's and then I was just like, no, there is a lot of physics in it. There's a lot of I mean even like something as simple as X-rays in medicine.
Mhm.
It uses the same they use the ray diagram analogy. A little bit of optics is also there to think in terms of how an image is formed, but all
Mhm.
of that just gets sort of takes a backseat, and I think that's what creates problems for students when they need to learn this material.
Okay. Okay.
Yeah, so that was a very nice point you brought up.
Good. Thank you. So how do I attend your painting class or uh,
uh,
class?
right now I do take some online classes.
Mhm.
I'm just start like it's very sporadic, so maybe I can, if I do take a session especially with this anamorphic art, I can definitely send it over to you. I do it
Okay.
online actually.
Okay. Okay. Just
Yeah.
share your number. I will be in touch.
Sure, sure. I think once Judah adds me to that group, then I can keep you in the loop.
Okay. Okay. Thank you.
Yeah, but great job, good presentation. I really loved it. Like it gave me so much to think about, and the history is amazing. I didn't know these facts about Galileo, and brilliant, just brilliant.
Oh, thank you.
Yeah, yeah.
Darren, I added you to the group. I just wanted to put you on the spot and ask if you can elaborate a little bit on what you meant on model-based reasoning.
Oh, right. Okay. So model based, okay. So this was based on a paper that I found. Okay. I mean, I'll just make it very simple. So in biology, like let's say if someone's studying something like, mitosis, like, right, cell division. Now, what happens is, for a lot of people, they don't have access to, especially images or resources that can show how mitosis actually looks like. Like they never witness it. So one of the ways of imparting an educational concept is by using a model that is constructed. So that model can be, like a visual model. So those usually help. So mitosis is usually shown by those two cells, right? And then they show the cell splitting. So there is so drawing has been used like back and forth by all scientists of all categories, right from physicists, chemists, botanists, biologists to, and especially back in the day, I think even you brought that point, the Galileo's paintings, right? I've seen that before, and scientists were well versed in drawing because they use it as a tool to communicate, their ideas and concepts to the public.
Yeah.
I mean, it's only very rarely they would hire someone else, but they would do it themselves. So, coming back to this model based reasoning, the idea is that we have two models, an internal model and an external model. So, the internal model is very abstract, right? Like we don't, we can probably visualize it in small ways. Like it will either be like some image or impression of something you witnessed, or of a concept that is interconnected. But the external models generally tend to be visual in nature, where you can like manipulate a process, and it also helps with memory because it there's a term called as cognitive offloading. So it allows you to sort of displace your cognitive effort onto a paper, for example, or onto a video that you're watching. So what this cognitive offloading does is sometimes it's very difficult to witness scientific phenomena that are really complex. And a good model will achieve what's needed to convey the scientific idea or fact to the learner. So that's model-based reasoning, like a gist of it. Does that communicate what? I mean, yeah. Did you get that?
One question
Oh,
I have.
yeah.
I don't know whether I got it fully, but still I will put this question.
Okay.
So how about what is that you meant by when you said putting the cognitive effort in the paper? You said something like,
Right. Right. So I give a very simple example. So my area of research was on spatial ability, right? So one way of cognitive offloading here is, remember when we were children, we would count with our fingers, right? Like 1, 2, 3, 4, 5. So we tend to use our own bodies sometimes as an extension of the mind, in a sense of displacing effort. So it is more easier to count with our fingers rather than putting in the conscious effort to do it, like in that abstract space called the mind. So one more way of cognitive offloading is by using a paper in front of you to solve physical, like, to draw a model of your ideas, equations in chemistry, because sometimes we need codifications to sort of restrict our thinking and also at the same time put it outside in the world so that we create space. So from a point of spatial ability, what happens is there are some people who find it very difficult to imagine certain phenomena. So I teach anatomy, and what happens is I teach anatomy to medical students. So this is a very well documented phenomena where they notice that some students struggle with visualizing a particular object. Like, let's say they have a car, and if you tell them, imagine how the back side of your car looks like. So they find it difficult to sort of do these tasks in their mind. But if there is an image in front of them or some sort of a video, it brings down the effort that they need to, grasp that visual idea. So,
okay,
yeah. So that's what cognitive offloading means.
okay, I see.
Yeah.
Interesting.
Yeah. Thanks.
I don't mean to make it long, but actually, when Darren said about model-based reasoning, in the context of Galileo and Kepler and Copernicus, I was thinking in terms of like, for example, when the model was about the circle, I would imagine like
Hello,
Yeah. Hello, Judah.
Judah, we lost you.
hello, can you hear me?
We lost you for some 30 seconds.
So what I was saying is, I was just wondering, like, imagining how model-based reasoning could be used to explain the history of scientific ideas. So, for example, when it was a circle, I wondered, like, what kind of explanations people had why it was a circle. Like, for example, people can keep a bucket on a string and turn the bucket around and be like, this is the constant thing, so like what kind of reasons people. So then I think once it became elliptical, people understood that it was something like, uh even if we put a elastic string and twirl the bucket around, it would kind of show something similar. So I'm just saying that maybe that the concept of gravitation, it wasn't something that Newton suddenly discovered. It is these gradual breaks in model-based reasoning that lent a hand in trying to come closer to what the reality is. So that was what I kind of wanted to say in terms of model-based reasoning in the context of history of science.
Okay.
I do agree with whatever he just mentioned, because Newton heavily borrowed from Galileo's work on. If you see the Galileo's work on gravity, it is as good as he has already formulated all the things required to predict that acceleration due to gravity constant itself. If you search for a experiment called Galileo table, it has everything other than the final equation what Newton mentioned. So, so all these people have nicely, though we just use one name to represent a complete integral of ideas, they have been integrating over a long period of time from various people and finally coming to a consolidated view. That's the only thing, like here Judah just mentioned. Yeah, that's right.
Yeah. And then that person who did that consolidated view stands out as the kind of
True, that.
yeah, the true contributor, right? That actually, as you said, yes, heavily Newton borrowed from Galileo, and for Einstein also, Lorentz transformation. A lot of things were already there when Einstein formulated his theory.
Yeah, Minkowski spaces.
Minkowski's case, Lorentz.
Correct.
Yeah.
And Newton acknowledged it by saying he is sitting on the shoulders of giants. Only
Yes.
that giants are not well named usually in our textbooks. It's the only thing.
Sitting
just
on
to add,
shoulders of giants, he chose not to name.
Possible. Just to add, if anamorphic art, if by any chance you are trying to, I will also be very happy to join in that. This Prasanna, by the way.
This question is to Darren, right?
Darren,
Yeah.
Prasanna wants to join anamorphic art
Yes,
classes.
yes.
Sure. All right. We'll work on something. I mean, yeah, I'll update you guys.
Yes, because I use heavily curvatures. So
Okay.
curvatures are one of the fundamental thing for ray, as you said, ray tracing and other detailing.
Okay. Is this like in 3D modeling?
Yes, more for one of the applications is anamorphism, but then there are many ways to use that information.
Okay.
I thought I
Okay, but what work do you do? Like, is it? Do you want to apply this to a work of something that you're doing?
as of now, it's more like making scientific models for students
Okay.
for them to understand what is cylindrical coordinate system, spherical coordinate system. But before
Okay.
introducing them in that coordinate system sense, what it does to, if I take a rectangular grid and show it in a plane, it reflects me as a rectangular grid. But if I take it
Right.
what is the distortion basically means?
Right.
A
Okay.
square, what happens to a square in each frame?
Okay.
I think
That's natural.
Yeah. Sure. I'll keep that in mind and work
Yeah,
something out.
thank you. Yeah.
Nice discussions. More than I talk, I learn a lot. Thank you.
Yeah.
Thanks.
Great. Good session, guys. Thanks.
Thank you. Have a good day. Bye.
Bye, everyone.
Thank you.